Okay, ladies and gentlemen, good morning. Welcome back to our lecture study theme on chain drives, Fenner Chain Drives. So today is going to be a fairly short lecture. We just have about 4 or 5 slides to just go through for the chain tensioning, so just a few installation and maintenance aspects that we're going to cover. But before we go through that, just to quickly review what we did for the previous two lectures. So we started off with a fairly elaborate example with regards to our Fenner Chain Drive design. We looked at 2 of the catalogs that we can use. So if we go to the Fenner catalogs that you have available on ClickUp, you'll see there's a Fenner Chain Drives selection catalog that you can use. And then if we also want to determine what our bush sizes are based on the shaft diameters, then we can also make use of this Fenner shaft fixings catalog. After we did that, we also looked at the example 2 and 3, which were the same as the first example. However, there we had a few space limitations. So we said what would happen if we want to change perhaps the sprocket sizes. We want to rather use smaller sprockets. Then we can go back to our catalogs and choose a speed ratio which is not involved. So a Fenner taper lock is not necessarily going to solve the problem, but we can still downscale our sprocket teeth a bit to get more spacing conventions or better space constraints. And then also example 3 also covered some space constraints that we looked at. And over there we said what would happen if we choose a chain pitch that is smaller than the one that we get from the graph. So in that case, perhaps I should just open it up. We go to Fenner Chain Drives, and remember that on page 4 we had this graph over here, and we said if we use the revolutions per minute of the faster shaft, and we use the design power, then we ended up over here with the 16B 1-inch chain pitch. So we can also make the choice deliberately to choose a smaller chain pitch. In this case, it was the 12B 3/4 inch. However, then our design power would probably require that we use, instead of a simplex design, we use a duplex design. Okay, so we increase the number of chains that we have to use. Okay, so then we also just said a few things to notice is that from this table as well, we're working with 19 teeth. So if we don't have 19 teeth over here, then we need to use some multiplication factor or sprocket factor, multiply our power rating by that, and then we need to compare it to our design power that we have, see if it's larger or not. Okay, so after that, I think we just looked at some chain tensioning techniques as well. So we said to increase the chain tension, we can use either idlers or chain tensioners, but we also have, I think it was on the previous page, we have these roll rings, which are quite effective when you have some sort of a space limitation. So in this case, you can just place this roll ring in between the 2 sprockets, and it will remain where it is and rotate together with the linear motion of the chains over here. So the important thing about chain tensioning is we just said you don't want your chain to be too tight. In that case, you're going to induce some additional preloads and forces on your shafts and the bearings as well, which is just going to cause premature degradation and failure of the system. Okay, if we leave too much slack, if your system is working at high speeds, you're probably going to have some vibrational effect, and that will then cause flexion in the chain as well. So it's going to cause damage to or wear on the chain that you don't want either. Right, so today we're then going to look at the next chain maintenance technique, and that is just with regards to lubrication. So Fenner also provides a product range for different lubrication types. Over here at the bottom, you will see you have this Fenner Plus lubrication-free chain. If we perhaps zoom in a bit, you'll see there is a breakdown of what they say over here. So you have some built-in lubrication. You have these sintered bushes for improved performance with the oil lubrication. And this is also for operating speeds of up to 2.5 meters per second. So over here, they also refer to a fit and forget reliability model. So you can just put this chain on and not have to worry about any lubrication that has to be applied. So on the other hand, we also have these Fenner classic robust chains. So in this case, it's shot peen rollers. We're going to look at where the rollers are located in just a moment, and the side plates as well. And it also makes use of these case hardened pins, the solid rollers for increased wear life, and we once again have this fit and forget reliability model that they apply to that. Okay, so depending on your application and your needs for lubrication, different Fenner products are available for that. Okay, so if we delve into the lubrication a bit more, so effective lubrication is essential in order to ensure optimum wear life from any chain. To be effective, it must form a film of lubricant between the wearing parts, so in other words, the pin and the bush of this chain mechanism. It therefore has to be suitable viscosity and delivered to the gap between the side plates such that it can penetrate into the space between the pin and the bush. Okay, so we actually have two clearances on these chain mechanisms. One that exists between the pin and the bush, and I think there's another one then between the roller and the bush, if I'm not mistaken. So we're just going to look at that in the next slide. So the viscosity, the amount and the type of lubricant is governed by the size of the chain and the operating conditions involved. So operating conditions would be the speed of your chain links, the RPM of your sprockets or your shafts that you have over there as well. Those things will influence how much of this lubricant you need and what type of viscosity or flowability of this lubricant you also require. So the oil will only penetrate into the bearing area of the chain when the chain is slack. Therefore, oil should be delivered to the slack strand just after the driver sprocket. So you'll remember as well from what we looked at for chain tensioning, we said this amount of slack is more or less 2% of the center distance that you have between your sprockets or your shafts. And then high-speed drives are especially critical. So these generally require a continuous stream of lubricant to be applied across the full chain width in order to act as a coolant as well as lubricating the actual bearing area that you're working with. Okay, so with that being said, we then have a few different types of lubrication that we can apply. So if I just zoom out over here, the first type that we have over here is lubrication type 1, which is a drip feed lubricator that we use. And this is for linear chain speeds that are relatively small, so up to 1 meters per second. Okay, so what I spoke about earlier, these side plates that we refer to, so we have these link plates, so you have some sort of an outer plate sitting over here, and then next to that you have a second inner plate over here. And between them there's a bit of a clearance. So you'll see over here, it shows these droplets of lubricant that you can apply into these clearances. So if you drop the lubricant in here, it will flow through and it will go and sit between the pin, which is this component over here, and then the bush as well, which is then this component sitting over here. Okay, and then additionally to that, you also have a second clearance, and this is then between the roller and the bush. So once again, if you drop the lubricant in here, it will go and sit between this outer roller that you have over here and then this bush that sits over here. Okay, so to perhaps just illustrate this in an exploded view as well, you will see this is more or less the setup that we have. So we have some pin that is going to keep the outer plates together. This pin is then forced through the inner plate over here, and then you also have these bushes and the roller that's going to sit on the outside. So making sure that you have sufficient lubrication will allow this chain to actually rotate so that you don't have additional friction. Okay, so just going back to our slides. So with regards to the first type of lubrication, the drip feed lubricator, oil drops are then directed between the side plate gaps with a drip feed lubricator. Here at the bottom you'll see there's just move this out of the way. So you'll see over here we have a drip feed lubricator. So we have these droplets that are then going to be fed into these clearances that we have over here. Alternatively, we can also make use of these brush applicators, provided that they are positioned to ensure that the oil is correctly delivered to the gap between the side plates. So the brush type is this one at the bottom over here. You can see there's a brush that is basically interfacing then with your chain links that you have over here. Okay, so this is now for linear chain speeds that are smaller than 1 meters per second. We then have a second lubrication type as well, which is this oil bath or disc lubricator, and this is for intermediate chain speeds, so anywhere from 1 to 6 meters per second. And in this case, you can see the oil bath that we are referring to. We have some sort of a container over here, and at the bottom we then have the drain plug, and we have some oil over here as well. So with the oil bath lubrication, the lowest strand of the chain then runs through an oil sump. So you'll see in red over here, you have these dashed lines, so this is your chain. So if I follow the chain down, you can see there's a small part over here that is going to be submerged in that chain as it's moving around the two sprockets. So with the chain running, the oil level in the sump should immerse the chain at its lowest point. We can alternatively also use a disc or an oil slinger, in which case the disc then picks up oil from the sump and deposits it on the chain, usually through some trial mechanism that we have. Okay, so it looks more or less the same over here. We just have an oil disc instead of an actual sprocket. So this oil disc will then pick up the oil and distribute it over this chain as it's moving around it. Okay, and then the last mechanism that we have is the type 3 lubrication, and this is for high-speed drives, so typically larger than 6 meters per second. And this is a pump and sump mechanism that we're using. So we still have some sort of an oil sump that's going to sit over here, but now we actually want to pump this oil out and distribute that over the chain that we have over here. So oil is pumped from the sump by a circulating pump capable of delivering a constant stream of oil, and this is then evenly distributed across the full width of the chain. The oil should then be supplied on the inside of the chain loop and at the lowest strand. So over here you can see I placed the hose or the outlet in between the lower and the upper strand that I have over here. So this is typically when chain speeds then exceed 10 meters per second. Okay, so these are extremely high speeds that we have over here. Okay, so that's then the 3 lubrication types that we have, and also the last slide that we looked at for the Fenner chain drives. So to quickly just show you what the catalogs look like. So you'll see over here we have Fenner chain installation maintenance. So if we quickly go to that one, you'll see it just contains the same information that we just went through, the different installations with regards to chain tension, and then we also have this lubrication section over here. If I zoom in a bit, you can see the information over there. Then there's just some installation instructions with regards to the taper lock mechanisms as well. So just how you have to install these sprockets. What is important to note is at the bottom of this page, you'll see there's this table over here. So with regards to the bush size that we select from our Fenner Chain Drives catalog, we can then go and determine what the different quantity or the properties are that we need to use. So for example, you have this screw tightening torque. So if I, for example, use the 2517 bush size, then I'm working with this 50 Newton meter torque over here. Okay, so just take note of this table as well. We might ask you in the exam or in an assessment, if you've now done your drive specification, what is the screw tightening torque that you might need? Or we can also ask you what is an appropriate egg socket size that you have to use for placement. Okay, so I think for the Fenner taper lock installation, so this is mainly the same as what we had for the maintenance installation. So you'll see over here as well, we just have a bit of a different system over here, but overall the installation notes remain the same, and we once again have this information once we have the bush sizes available. Okay, so I think that's more or less all of the catalogs that we wanted to go through. So just another spreadsheet that I haven't uploaded yet, but I'll do that after today, is just with regards to your chain selection criteria. So I've created this new Fenner Chain Drive example 1 spreadsheet. So if we go to this one, and I zoom in a bit. Okay, so the chain drive selection sheet. So first I just give the design data that you would need. This is taken from the Fenner catalogs as well. And then over here we just have the description. So I've just listed that out. Depending on the information that we have available, you can then populate this field over here. So with regards to example 1, you'll remember that we worked with an electric motor. The electric motor starting arrangement will then be direct online. Rotational speed of the prime mover, the power rating of the prime mover, all of these properties were then given. So this power absorbed by the driven machine, I don't think this was given. So I just said to be determined over here. And then we also have the duty hours, the driver shaft, the driven shaft diameters, center distances. We didn't have any space restraints or any other issues that we needed to take into account for example 1. So I just set none over here. And then you have this stepwise calculation of the chain drive properties as well. So we always start off with a service factor. We can get this from table 1, and you'll remember that that was 1.2. Then we got the design power. I'm not sure why this one. Okay, yeah, so I'll just have to go and double check this one. I think this is a mistake on, see if we use D40 and K29. So I just want to check if we go back up. So this should actually be your service factor multiplied by the power rating. Okay, and that should give you 1.8 kilowatts. Then we also determined the chain pitch. So this was from table 2, or that graph that we had available. So there we got it 16B 1 inch, so 25.4 millimeter pitch that we're working with over there. The speed ratio as well, we calculated from the speed of the faster shaft, which I think I've listed over here. So this is prime mover, so that's 80 divided by 40, and that then gives us a speed ratio of 2. Once we had that available, we went over to the sprocket sizes. We got those from table 4. And for the driving sprocket, we had 19 teeth, and for the driven sprocket, then 38 teeth. Regarding the power rating then, we got that from the power rating table. So that is, if I go back to, I think it was this one. So this is then on page 5, where you have your power rating tables. We got this from the 16B table. At 80 RPM for a simplex design, we had this 3.79 kilowatts. So if we look back over here, you'll see it's 3.79. And then we just ask, is this power rating then greater than or equal to the design power? Yes, it is. So then we can use the simplex design. So you can also update this if you, instead of using a simplex design, you want to use a duplex or triplex, you can just change it over here. So if I were to select duplex, then you'll see the number of chains also updated to 2. Okay, but for our design, we're using a simplex, so that's fine. And then lastly, it was just the chain length calculation. So you'll remember that we did these calculations from Excel previously as well. So this is just a bit more organized. So in this case, you have the center distance, the pitch of the chain, you find them in table 5. The number of teeth on the large and small sprockets as well. So we already know that from the previous calculation. The K factor we find from table 3 as 9, and then we can go and calculate the length of the chaining pitches. So in this case, I made it 107, or I think if we actually use the recommended center distance, I think that was 1000 millimeters. Then you'll see that the length of the chaining pitches is this 107.5. The rounded value that we want is 108. So if we calculate the difference between them, we get this 0.53 pitches. And if we then want to use the actual center distance, we're just going to do it goal seek. So I'm just going over to data. And then you'll see there's a what if analysis over here. So you can either use goal seek, or what I like to use for these problems is the solver. So if I click on solver, then I just have to say I want to set this cell to a value of 0 by changing the variable cell, which is then this one over here. And then I can click on solve. Click on OK, and now you can see the value, the difference over here is almost 0, so that's fine. And my new center distance is then 1006.8. Okay, and then lastly, I think we just brushed over this chain length in SI units. So all that you have to do over here is, you'll see I take the chain length in pitches and I multiply that by this D52. So D52 is then the pitch of the chain in millimeters. Okay, so if I hit enter, then I can see my chain length in SI units is actually this 2.74 meters that I have over here. Okay, and then I can just go to the driver sprocket selection as well. So this you will have to manually work out or find. So this is just from page 22 where we find that. So it's 2517 bush number, and then I think the 8119 is your designation that you get in that table. And then the same for the driven sprocket as well. Okay, and then over here I can just summarize everything. So I now know what the number of pitches are. I know what the chain length is in millimeters. I know it's a Fenner 16B-1. All of that I got from the table. And then 8119 driver sprocket with its sizes. And then also this driven sprocket with its sizes. So I think over here it should actually just see. So I think we just have to update. I'll just update this one because it should say 2517 by 35 and 3020 by 65. Okay, so I think this more or less then covers the spreadsheet. So I think there was just a last comment that I wanted to make on one of the slides where we looked at the number of teeth on your chain. I think it was this one. Was it previously? I think it was somewhere. So we said that an even number or an uneven number of drive sprocket teeth should interfere or engage with an even number of driven sprocket teeth. So I think that was the mistake that I made over there. So it's actually, if you have an odd number of driver sprocket teeth, then you rather want an even number of pitches on your chain. So I think that's the correct statement over there. Your number of teeth on the driver and driven sprocket will depend on whatever your speed ratio is. So you might very well get a speed ratio where you have, let's say, an uneven or an odd number of sprocket teeth on both your driver and your driven sprockets. Okay, so just take note of that as well. Yeah, so I think that more or less then sums up what we wanted to do for Fenner chain maintenance and the chain drive slides. So are there any questions with regards to this study theme? Yes. Yeah, so I think there was a slide that said if you have an odd number of driver sprocket teeth, then you actually want an even number of chain pitches. So you'll see in the problems that we looked at as well, whenever we got the value for the chain length, what we wanted to do is then round up to an even number. So it's just important that you remember that if you have that odd number, then you round up to an even number. Yeah. So I think the original mistake that I made over there was just to say that if you have an odd number of sprocket teeth on your driver, then you need an even number of sprocket teeth on your driven gear or your driven sprocket, which is not correct. The actual number of teeth will depend on the speed ratio that you have available. Okay. All right. Any other questions? Okay. All right. So I think in that case, ladies and gentlemen, then we're done with this study theme. Yeah. So it was a fairly short session. Next week we'll start with a new study theme. So then I'll see you again. All right. Thank you.